Hello, ladies and gentlemen. Welcome to the video where I'm going to discuss how to solve each problem from the back of the take-home quiz algebraically. Okay, there will be some parts where we pull the calculator out, but this is where we're going to do most of this by hand. This is kind of the way that I taught it, just going straight through the class. And then as we've talked more, I realized that we might want to do a little bit more work with the calculator. So if you want to check the calculator video out, the link to that's in the comments. I've always wanted to say that. The link to that video will be in the comments for this. But for now, let's go through how to solve each of these problems algebraically. Now, for these first two, I have all this explanation on how to do it algebraically, and then I say just use the calculator and the change of base formula, because even if you're doing this algebraically, I want you to just use the calculator on these ones. So to type these into your calculator, get out of that, clear, and it's just log of the big number divided by log of the small number, okay? Log of the argument, 24, divided by log of the base, 5. Press enter, you get a funky decimal, and that's exactly what we're looking for, okay? So we end up with an answer of 1.9746, okay? And that's all we've got to deal with for that one, all right? Take a minute, pause the video, and try the next one on your own. A little trickier because of the fraction, but I think you can handle it. Okay, prove me right. Log of 5 divided by 4, close parentheses, divided by log of 5, close parentheses, enter. You should have got this, I got this. Just make sure your parentheses are all in the right spot, and you should be good to go. 0.1386, okay? Now, this next part is this awfully printed dark gray box. I was trying to make it easier to read and made it significantly harder. Didn't have time to fix it when I was gone, but it's basically just breaking down how to use the calculator. But this video, we're going to break it down how we're going to do it in by hand. So to do this, we're going to use some of our section 7.5, how to combine logarithms rules. And I know that if I have one log with this base and another log with the same base, and I'm subtracting them, then I can divide their two arguments and write it as one single logarithm. So I have log base 7 of the first argument, x minus 3, over the second argument, x minus 6. And that equals log base 7 of 6. Now, what's nice about the algebraic method is once I get to here, log base 7 on both sides, those cancel out. And so all I have is x minus 3 over x minus 6 equals 6, okay? And this actually becomes fairly easy to solve after this. We just don't do a lot of problems like this yet, although it's all we're doing in chapter 8, so it's good for you to get prepared. For the sake of clarity, let's rewrite this. X minus 3 over x minus 6 equals 6. And then we're going to get rid of the denominator, because that's what always makes these things so difficult, by multiplying both sides by that denominator. If I multiply the left side by the denominator, I know it's just going to cancel out because that'll equal 1. And all I have is 6 times x minus 6. So x minus 3 equals 6x minus 36. Mr. Young, did you just distribute all in the same step? I sure did. I sure did. Okay. But what's nice about doing that is now this becomes a lot easier to solve, because now I can subtract 3 from both sides. And so I'll get, I'm going to subtract x from both sides. I misspoke. I'll get 5x, and I'll add 36 to both sides. Negative 3 plus 36 is 33. So I get 33 equals 5x, and then just divide both sides by 5. Boy, we're running out of space there, but, you know, there it is. And now I come over to my calculator, because who wants to do that kind of work in their head? 33 divided by 5 is 6.6. Okay, there it is, right? And I should say x equals 6.6 if I want to be thorough here, okay? Now, there's not really enough space to do these on these problems, and I will strongly recommend both on the take-home and on the actual test that you do your work on a separate sheet of paper. Give yourself that space to work, but for the sake of the video, I've got extra copies, and I'm just going to use a fresh copy for every problem. But that's what we're looking at here for number 18, okay? Take a moment if you got to go back. Now's a good time. Otherwise, I'm going to move on to 19. Now, I've got 5 to the n minus 2 equals 160. Now, again, Section 7.2 problems like what are on the front, those are the problems where you can make them both have the same base. But there's no way I'm going to rewrite 160 as 5 to some power. It's not a power of 5. So I can't do that. So instead, I have to take the log of both sides. So I end up with log of 5. And the common log is fine, right? Log base 10 to the n minus 2 equals log of 160. And the reason I do that is because now this exponent can be moved up front. So I end up with parentheses n minus 2 log of 5 equals log of 160. Now, if I remind myself that log of 5 is just a number, then this is some number times some other number, n minus 2. So I can divide both sides by log of 5, and I'll be able to get the n minus 2 by itself. Now, it's going to be an ugly decimal, but I can still do it. So with my little bit of space down here, log of 5 over log of 160. And this will cancel out. And I'll get n minus 2 equals log 160 divided by log of 5. Oops, I wrote that wrong, didn't I? For all of you guys who are confused, you were right, I was wrong. I wrote the wrong logarithm. Log of 5 on this side, log of 5 on that side. Divide both sides by the same number. And I get 3.1534, right? Still going to 4 decimal places, okay? Now I got to get n by itself, so I, add 2 to both sides. N equals 5.1534. And if you need to, you can type that in the calculator. I won't judge you. I won't even be watching you, okay? So there's our answer. N equals 5.1534. Okay, try and check your rounding. All right. Good time to pause the video, rewatch anything you need to. I'm going to switch sheets here so we can have a clean space to work for number 20 and 21. Okay. Now, for number 20, same thing. I cannot write 6 and 9 as as any each other any same base. Right, you might think with a 3 you could, but it's 3 times 2, not 3 squared, so there's no way to really make that work. So we're stuck with, again, taking the log of both sides. Now, I get log of 6 to the n plus 2 equals log of 9 to the n. And then for both of these, I'm going to make the exponent come up front. Okay, so this will be n plus 2 log 6 equals n log 9. Okay. Now, this is kind of helpful. I mean, it's still going to be pretty ugly here pretty quick with the decimals we're going to have to work with. But what I can do is I'm going to distribute log 6 on the left side, and we'll leave log 9 as it is right here on the right, but we're going to write it as a decimal. So we're just going to convert all this into decimals and then work with them from there. Again, it's not pretty, but if we ignore the fact that it's decimals, it actually becomes pretty basic. So if I distribute log of 6, which log of 6 is 0.7781, then this becomes 0.7781n, right? Distribute that there, plus 2 times log of 6, which if I just take that 2 times log of 6, I get plus 1.5563. Okay, that equals log of 9n. Log of 9 is 9542 n. Okay. Now, it may not look like it, but now I just have a relatively simple linear equation, right, to solve. I just have to get all the n's on one side and then divide by the coefficient. So what's 0.9542 minus 0.7781? Well, I don't know, but I can type it in the calculator, right? So 0.9542 9542 minus 0.7781, So I end up with 1.5563 equals 0.1761 n. Okay, I've just moved the n's over to the right side. It's nothing we haven't done 1,000 times before. Then what's my next step? Even if it said 2, you'd know what to do. So if it says 0.1761 times n, you know what to do. Divide by 0.1761, divide by 0.1761. And that'll cancel, and I'll get, let's see, 1.5563 divided by 0.1761, and press enter, and I'll get 8.83, let's see, 759 will just be 76, yeah, equals n. All right? And that should work. That should work. Okay? 8.8376. All right? So there's that one. Okay? Again, pause if you need to, rewind if you need to. And then for this next one, we're in the same situation, right? We can't write 80 as some power of 7. So we take the log of both sides. I'll work over here. Log of 7 to the 5x minus 3 equals, well, yeah, we'll stick with this, is less than 80. Oops, sorry. Log of 80. Like I said, just like the real class. Log of 80. Okay. Bring this down. 5x minus 3 times log of 7 is less than log of 80. Divide both sides by log of 7, just like we did up here for number 19, right? Oh, yeah. 5x minus 3 is less than log of 80 over log of 7. This will come out to an ugly decimal, but we can still work with it. Log of 80 divided by log of 7. So it comes out to 2.2519. 5x minus 3 is less than 2.2519. And then you add 3 to both sides. You divide both sides by 5, just like any other regular equation. So plus 3 divided by 5, x equals 1.0504. There you have it. Okay? All right, then. So there's that one. There's those first, these are the 4 toughest problems, I think. If you can get through these, you're in pretty good shape. On the next one, it's just change of base, okay? And I'm going to go back to the other one because it will be a little cleaner. Well, nope, we'll just get a clean one. Okay? There you go. Much prettier. Log of 15 divided by log of 25. That's what they're looking for here. Log of 15 divided by log of 25. That's just that change of base. Log of the big number divided by log of the smaller number. Then they want the approximate value, so just toss in the calculator. Log of 15 divided by log of 25. Oops, there we go. Answer comes out to 0.8413. Okay, there's that one. Pause if you need to. Next one, simple interest problem, okay? I give you the formula, all right? Suppose you deposit $1,500 into an account. There's your P. It's paying 5.5% annual interest. There's your R, but you have to write it as a decimal. Compounded continuously. Okay, yep, we're using E. Got it. Find the balance after 8 years. There's your T. I give you P, R, and T, and the calculator knows E. You got everything you need. Plug it in. A equals 1,500 E to the 0.055, right? Write that as a decimal, times 8 for T. Throw it right in here. 1,500 e to the 0.055 times 8, close parentheses. And you get $2,329.06. That's it. Round to the nearest penny, we even did that. $2,329.06. Make your math teacher happy by putting your units in. Make your students happy by making the screen visible. Whoop, excuse me. All right. And we're good. That one's all set, okay? Now, for these next two problems, it's a lot of the same thing, but we're gonna kind of focus on the change it into exponential form approach. So up here, especially for like 19 and 21, one of the things that makes chapter 7 difficult is there's more than one way to solve this, right? I focused on the put the log on both sides and move the exponent up front method. That works. The other method that works a lot and that we're going to use here is that idea of going into exponential form where the base stays the same and the others two flip. So if we remember that the base here is e, anytime I see natural log, it's the base of e, and then we flip these two numbers, this becomes, and I know some kids like to go ahead and write it, so log base e of x minus 3 equals 2. Base stays the same, and the others flip, right? A lot of people really like this method because now this is just another number. It's going to be a decimal, but it's just a number. And then we're going to add 3 to both sides and then have x by itself. So e squared, second e to the second power, is 7.3891. 7.3891 equals x minus 3. Add 3 to both sides. I'll even write it out for you. 10.3891 equals x. And you're done, right? That's it. X equals that. No tricks, no schemes. Okay, that's all it is. That's what's nice about having multiple methods, because sometimes it's really easy to just go ahead and change it into exponential form and work from there. Now, here, okay, different, because now I already have the base of e, so now I want to go ahead and put it in. I guess it doesn't really matter how you think of it. Let's stick with what we were saying. We're going to change this out of exponential form into logarithmic form. And I always get excited because I've been doing this long enough. I know that when I see a base of e, to take the log of both sides, give both sides to take the log of both sides, to change this into logarithmic form, it just becomes natural log of 49 is less than or equal to negative 4x, okay? Now, let's walk through what I just did there. Remember, the base stays the same and the others flip. So what I really had was log base e, flip the others, and then anytime I have an inequality, I have to remember to flip the inequality sign, negative 4x, okay? So I got a little tongue-tied there, I apologize, but that's what we're doing, okay? We're just changing it into logarithmic form, just the same as we took this one out of logarithmic form and put it into exponential form. Why do we do that? Because now I just have a number. Natural log of 49, I can type that in the calculator, right? Remember, the natural log button's right here. Natural log of 49. So you get 3.8918 is less than or equal to negative 4x. All right? Now, to get x by itself, just divide by negative 4. Nothing we haven't done 1,000 times. This goes away. Divide by a negative, so this has to flip. And we divide that number by negative 4, excuse me. And so we get negative 0.9730 because the 5 would round it up and so on, okay? So we have negative 0.9730 is greater than or equal to x. I would accept that. Of course, my preference is to have the x on the right, or excuse me, on the left, which means I then have to flip the sign one more time, negative 0.9730. Okay. Finally, we have to write this as a single logarithm, and there's nothing the calculator is going to do to help us anyway on this one, so we just have to do it algebraically. I know that if I've got two logarithms with the same base, these both have a base of e, they're both natural logs, I can then just multiply the two arguments because I'm adding the two logarithms together. So I get natural log of 5x, because x times 5 is 5x, minus 3 natural log of y. And I also know that if I have 3 times a logarithm, that 3 can become an exponent here. So natural log of 5x minus natural log of y cubed. And then, just as when I was adding the two logarithms, I multiplied the arguments, when I'm subtracting the two logarithms, I can divide the two arguments. So I end up with a final answer of natural log of the first argument, 5x, divided by the second argument, y cubed. Okay? And that's it. Excuse me. We will discuss a little bit more interest in class, and I think it also kind of links into the extra credit problem that's on the actual test itself, so I won't give away too much on that one, but you've now seen how to do each of these problems algebraically. We will do more practice in class with both methods. Like I said, if you want to check out the calculator video, by God, do so, and then bring any questions that you have either to me via Remind or bring them to class on Monday. And last but not least, you're watching the video, you're a good boy / good girl, and now I need you to tell your friends to do the same thing, because yeah, if I'm gonna spend an hour and a half on a Saturday making a video, I'd love for you guys to spend 20 minutes watching it. So please and thank you for your participation. To use an old phrase, we do it for the kids, and you guys are the kids, so please take advantage of this opportunity. We're bumping the test back. I'm begging you. Watch this stuff, learn from it, come in with questions so we can have a productive day on Monday and have a solid test on Tuesday. All right, I love you guys and thank you for watching.